Hi, this is Jeff Black, and this is my cell membrane. These two combined are the phospholipid bilayer. These are my phosphate heads, and these are my fatty acid tails. This is my channel protein. These blue beads are my cholesterol. This is my peripheral protein. This is my glycoprotein, and this is my glycolipid. This represents the fluid mosaic model because the different parts or proteins and materials can move on freely inside this membrane. And it's mosaic because it looks like a pattern if you look at it from above. Cell transportation is necessary because it maintains homeostasis. Now for passive transports. The first passive transport I'm going to use is diffusion. Diffusion is movement of particles from a region of high concentration to low concentration. Molecules are being moved and the concentration gradient is from high to low. Now time to demonstrate it. So the molecules go through the heads and the tails in between them and then out to the other side. Now for the second passive transport. The second passive transport is osmosis. Osmosis is diffusion but involves only water molecules. Diffusion doesn't involve water molecules. And the concentration gradient is from high to low. Now time to demonstrate it. The water molecule, which is the blue beads, go through the heads and the tails in between and out the other side. The third passive transport is facilitated diffusion. Facilitated diffusion is when a molecule is too big and cannot fit in between the membrane. So it has to have a carrier protein to help it get across. It's from high to low concentration, and the substance is being moved are big molecules. Now time to demonstrate it. So the big molecule goes through the transportation protein and out the other side. Now time for active transport. The first active transport is the sodium-potassium pump. The sodium-potassium pump requires ATP to move from low to high concentration gradient, and it uses a carrier protein to move sodium and potassium ions across the membrane. The substances being moved are sodium and potassium. So the second active transport is endocytosis. Endocytosis is when a material is too big and it has to be engulfed by the cell to go into the cell. It requires ATP also, and the particle forms a vesicle around it and goes inside the cell from low concentration gradient to high concentration gradient. And then the third active transport is the exact opposite. It's exocytosis. It requires ATP again and is moving out of the cell, while endocytosis is moving into the cell. And it forms a vesicle around it and moves out of the cell. And it's big particles that are being moved, and that's it. Thank you for watching.